I am uber caffeinated. I suppose I should. Yeah, I suppose I should play this. Okay, so I'm giving a talk. It is called "Yak Shaving is Best Shaving," and this is my talk. Hello, world. I am very, very nervous on stage, but at least here at Madison Ruby, there is a gnome in the front row that I can look at and feel comfortable, hopefully. um, typically, I wear a suit while I'm on stage, but I've gained a little weight, so today I'm wearing a stretchable suit. Yes. So my name is Aaron Patterson. I am on the internet as Tenderlove, and you might recognize me more for this photo. I have a couple cats. This is one of them. Her name is SeaTac Airport YouTube Choo Choo. And this one is my other one. He's a bit more famous. This is Gorbachev Puff Puff Thunderhorse III. Both of them are my pair programmers. So I'm on the Rails core team, and I'm also on the Ruby core team. I work at a company called AT&T, and they employ me to do open source programming all day. And so what I do is I just program open source all day, which is a pretty cool job. So you'd think like, wow, AT&T is a big corporation. They must be like super bureaucratic and stuff. How can you have a job doing open source? And I'm here to tell you it is not bureaucratic at all, not whatsoever. And if you don't believe me, you can send me an email at work. This is my work email address. I'm not joking. This is actually my work email address. I actually working at a giant company is kind of interesting because there are many other people named Aaron Patterson who work there as well. And so I get a lot of wrong emails, which is kind of weird. Anyway, so I'm really excited to be here. For me, Madison is a whole bunch of firsts. First time experiencing things. Like this morning, I saw Brian Lyles drink dog hair. That was the first time I've seen anyone do that. Sorry. I'm really excited to be here. If you are too, you should tweet with Mad Ruby 13. All I could think was this. Anyway, so I'm staying at the Hilton. And I'm part of their honors program. And so I thought, oh, honors, H honors, it stands for Hilton Honors. And then I showed up, and it was this. And when I signed in, I'm not sure how to pronounce this. When I signed in at the thing, I said, yes, am I on? Because I didn't give them my number at first, so I checked in and I was like, yeah, can you associate this with my honors account? And the lady looked at me weird. So, I don't know. Anyway, so I'm incredibly honored to be here. So, I'm excited to be here in Madison. I'm really excited to be here. I'm a huge, one of the things I like to do in my spare time is making collages. So I'm really excited because I heard that Madison is a huge collage town. So I made a collage for all of you. Has Madison. This is I ate it where did I Chipotle. This is the first time I've ever eaten at Chipotle, and it was delicious. My coworkers will not go with me to Chipotle, so this is the first time I ever got to go there. So that was exciting. I found out that honors does not stand for Hilton Honors. I heard of this guy that's famous here, Scooter. Yes. What's his name? What's the correct name? Thong Cape Scooter Man. I kept Googling for him, and I kept putting it in the wrong order. Thong Cape Scooter Man. I also ate this this kind of pizza. This is a macaroni and cheese pizza. I ate this. Yeah. Anyway, so this collage is unfinished because I never finished collage. And so if you like collages too, I'm thinking about starting a website where you can put together funny collages and share them. I'm going to call it collage. I have to credit Phil for that joke. Anyway, I'll continue. So I wanted to like connect with developers in Madison before I came here. So like whenever I go speak somewhere, I like to research about the place I'm going and like figure out what the people there are like, and so I can try to relate to them. So what I did is I found out about this guy, this thong cape scooter man, and I was like, well, I really want to connect with the people, the folks in Madison, so that's me. And I bought a thong and a cape. So I got that, and like, so this is like a challenge to me. It was a first for me. This is my personal challenge. And I put on the cape. Equipping the cape was fairly simple and straightforward, and then equipping the thong was a bit more difficult, but I did that. This is the first time I've ever worn thong underwear. And so I said there's a lot of firsts. And if you want to know what it feels like to wear thong underwear and you've never worn it before, like basically this is what it feels like. So there's basically two. Oh, I also own a scooter. I failed to mention that. But there's basically two problems with this thong underwear. The first problem is it goes all the way up. All the way up. And I'm a very hairy man. The other problem is my scooter has a black plastic seat. So not exactly comfortable. Anyway, my wife refused to take photos of me outside. So there's no photos of that. And I may or may not post these slides. I'm not sure. Anyway, so what is yak shaving? The thing you know about yak shaving is it can get pretty hairy. So one of my favorite things about being up on stage and giving talks, especially in the presence of my coworkers, is that I can make as many puns as I want to, and there's nothing they can do about it. Anyway, so yak shaving. Yak shaving is when you set off to do a particular task, and you end up doing that seems to be completely unrelated. Seems to be completely unrelated to that task. So what I want to do today is I want to talk about some stuff that I've done that was all yak shaves. So all the things I'm going to talk about today were all yak shaves. And the thing is, like, I have a really, really short attention span, so I get distracted pretty easily. So some of the stuff we're going to talk about, it's related to what I wanted to do, but not entirely related. So I think it's more of like yak meandering or something, and you'll kind of see what I mean. We're going to get into it here. So, all right. So I'm working on the codes, and I run into this bug. And it's like, oh, okay, I select 10 as n, and I do .n, and it comes out to be a string. And this is a bug in Rails on Postgres only. It's only on Postgres. So I'm like, okay, let's fix it. Let's fix this bug. Let's fix it. All right? Fix the bug. So we're going to do that. And the first topic I'm going to cover, like I'm going to give you a little general topic and we'll go into it. This is kind of a preview. The first thing we're going to look at is runtime and security, runtime speed, and we're also going to look a little bit at security. So we want to fix this bug, and the first thing that we need to do to fix this bug is, well, we see that we're calling this method to access an attribute, so we need to figure out how that's defined or what that method is. So what we do is we create a new class like this, a user class. And one thing to note here, which I don't think many people know, is that established connection here in Active Record actually takes a URL. So you can give it a URL of parameters. You don't have to like give it a whole big old hash or whatever. You can supply just a straight URL. What I'm doing here is just connecting to an in-memory database in SQLite. And then I create a user, just a user model with an attribute, and we want to figure out where that attribute is defined. So we're going to go do that. And what's interesting is when we try to find that instance method, it's not actually going to be there at first. So if we try to access the instance method on the class, we'll get a name error, and it's because these attributes are lazily defined. So after we create the model, after we just create one instance of it, then we'll find that instance method is created. So first thing we do is say, okay, well, I wasn't able to figure out where that method was at first. After I create one, okay, I can figure it out, so create one. And we go look it up, figure out, well, where is that? What is the return value of this? We see, well, at first, we see it's a method not found, it's not defined, but then we see, okay, it's an unbound method, and what this is telling us is that it's defined on a module. It's defined on a module, and the method is named name, but it's an alias of this weird, like, generated name thing here, right? And what we can do is we can call .sourceLocation on that unbound method, and it'll actually tell us where in the source code it's defined. So if we call sourceLocation, we can figure out what file and line number where that method is defined. So we go take a look at that, and this is what it looks like here. And you don't need to read this. I'm just going to explain what's going on here. Is we define a method here. This is the go. Right there is the original name of the method. That's that weird one, the under temp thingamajig. That's the original name. And then down here, we alias it off to your name and the name in your database. And the reason we do that is because you could have like weird column names that aren't legal to do under def. We can't say def that string. So we actually alias it over. So to understand how this works, we look at this code, and the first thing I do when I'm looking at this to understand is I try to simplify it. And that stuff, that peripheral stuff, it didn't really matter with regard to the bug that we're trying to deal with, right? So really what I want to do is I want to look at the body of this method. And we look at the body, and it says like, okay, this is really the body. This is where most of the work is happening. And we see, we're calling read attribute, and we notice there it's creating a string, or a symbol, excuse me. We notice it's creating a symbol, and all of your attributes are stored in a hash by symbols. So we look all of them up by a symbol, and I'm sitting there thinking, well, that's kind of weird. We look all those up by symbols. Well, symbols in Ruby don't get garbage collected. So if we use symbols and the input is dynamic, we can leak a lot of memory. And this is a vector for people to make our processes leak memory. So for example, this code right here will just continue forever until the process runs out of memory, and then it'll die, right? Now, this shouldn't really be a problem because the columns in your database are bounded. You only have a set number of columns in your database. So hopefully we only create that number of symbols. But the problem is that you can actually do dynamic lookups on your active record models. So you can do this. You can say, well, treat it as a hash, and whatever thing I put in that hash, I'm going to go look that up. And what can happen is if we get dangerous input, like input from the params hash or something, we're going to go convert that to a symbol. Maybe it's a dynamic value. We'll go convert it to a symbol and go look it up in the hash, and now we have a vector for a denial of service attack on your application. So I decide, well, okay, let's fix that. I'd rather look up these values by strings, since strings will get garbage collected, so we just change this to use a string instead. And we say, okay, well, now it's a string, now it's defined as a string, and all the keys are strings, and now we don't have a chance of this denial of service attack, so we're all happy now. But then we run our benchmarks, and somebody complains like, oh man, this is slower. The implementation is slower. So we think, well, why is it slower? And we notice, well, it's generating a lot of garbage. This code is generating a lot of garbage whenever we call an attribute method. So why is it doing that? Well, let's super simplify. Super simplified, this is just one attribute we call read attribute on name. We think, okay, well, how is this code generating a lot of garbage? It's not really doing anything. We're just looking up some value. What's it doing? So if we take Ruby's instruction sequence API and look at the instruction sequences for this, we can see what the virtual machine is actually executing. So this is the byte code for that particular slice of code. This is using a symbol. So if we were accessing it via a symbol, this is what the byte code would be. And now if we access it via string, this is what the byte code would be. And if we look at the difference between these two instruction sequences, we can see there's one difference. We have a put object in the symbol case, and we have a put string in the other case. And just as a side note here, when you access these instruction sequences, and despite my earlier comment, I will put these slides online. They may not have the pictures in them. But these slides will be online, so if you want to read the code later, you can. So what's interesting is that we can actually convert these instruction sequences to arrays. So if we want to, in Ruby, we can actually do diffs on the instruction sequences, which is interesting. I want you to mull that over in your head and think about the interesting ways you can use these instruction sequences. But anyway, let's look at the definitions of these instruction sequences. We had two, put object and put string. So, okay, well, where are those defined? We go look in insns.def and Ruby source. This is where all the instruction sequences are defined. If you go look in that file, you'll find all of them with documentation above each of them for what they do. This is the put object instruction. The Ruby VM is a stack-based virtual machine, so all this does is just pushes a value onto the stack. It literally does nothing. So it's taking that symbol, pushing it onto the stack. That's all it does. Now we go look at put string. Well, this does something else. This does something more interesting. We go, okay, well, let's go look at RB stir resurrect. We go look at RB stir resurrect, and we see down here, string alloc, stir alloc. So every time we have a string literal, we're actually allocating a new string. It's actually allocating something, and you can see this very simply. If you do a bit of code like this, we'll just loop over a string literal and output the object ID, and you can see it changes on every call to that block. And that's because in Ruby, strings are mutable, right? Every time we evaluate that string, we have to generate a new one because it could get modified at some point in the future. So can we have the best of both worlds? We want to have the speed of this symbol, but it would be nice if we could have the safety of the string. Strings will get garbage collected if somebody is sending in looking up active record attributes by dynamic values. It would be nice if we could just garbage collect those strings and let them go away and not have this be a vector. So how can we have the best of both worlds? And the answer is use a constant. So we can define a constant with that string and then have our method body just look up by the constant. And if we go look at the instruction sequences for this, here are the instruction sequences. The main one to look at is we have one called getConstant. If we go look at the source for getConstant, we see, okay, well, it goes and looks up VM getEnvConst. What is this? Eventually, if we jump around in these methods, we'll eventually get to a function called rbconstGetZero. And we see in there this stlookup call, which is just a hash lookup. All we're doing is looking up that constant name in a hash and then just returning the value. Right? So we're getting a constant time lookup for this value. And when we use a constant like this, we don't get any new allocations. So no new allocations. Well, cool, that's cool, Aaron, but is it as fast? So let's write a benchmark. We have a very tiny benchmark here. All it does is define three methods. One looks up by a string, one by symbol, and the other by a constant. We benchmark this, run the results, and we'll see actually that the constant speed is about the same as the symbol speed. It's difficult to tell which one's faster in this case because the standard deviation is too high. But they're very similar. The string one is significantly slower. So we change the implementation. If you go look at the implementation in Rails today, you'll see something like this where we just define a constant. We define this constant, and then your dynamic method goes and looks up by that constant. So we get the speed of symbols with the safety of strings. So, okay, cool. The next thing we've made that faster, still haven't fixed the bug. We're a little bit safer, right? Still haven't fixed the bug. And then we think, we're looking around in this code. Next thing we're going to talk about is memory consumption and boot time. We're looking around in this code, and we look at this method, and a lot of times, I'm just looking at the code, and like, I read a comment and I'm like, why did they say that? Why did they say that? There's this big block above it, and I read the comment, and it says, we want to generate methods via module eval rather than define method because define method is slower on dispatch and uses more memory because it creates a closure. And I'm thinking to myself, really? Define method is slower on dispatch? Is that true? I don't know if that's true. And then it says, and uses more memory. Is that true too? I'm not sure if that's true. So then I'm like, well, I got to test this. rather than fixing a bug. I got to know, is this true? So I write a benchmark. I'm like, okay, so we eval this. We've got one here that's one method that's defined with define method, and another one that's defined with module eval. We go ahead and run that, and the define method one is slower when we call it. Define method one is, in fact, slower when we call it. Like, that's interesting. I didn't know that. And then I'm like, well, let's look at the documentation for define method. So I go look at that, and I'm like, wow, that's interesting. There's actually two different ways to call define method. There's one with a block, and then there's another one with a method object. You can actually give it a method object. Well, I wonder how that one performs. So I write a benchmark for this as well. Basically, what we do here is we say, okay, let's define a method with a block, and then let's define another method, but we'll just copy that foo method. We'll define a method using the foo method, and we run that, and if we look at the benchmark results for that, the one with define method, the define method with a method object is actually the same speed as the module eval one. It's exactly the same speed. So when you read this comment, you think, well, is module eval faster than define method? And the answer is, well, it depends. It depends on how you use it. The comment did not mention that, so it's not particularly accurate, so let's refactor our comment. Okay. So very important. So we refactor the comment. It says it's slower on dispatch. Well, that's not necessarily true, so delete. Okay, let's look at the next part. We got a next part in here. Define method uses more memory because it creates a closure. And what this is talking about is that when you call define method with a block, that's actually creating a closure and keeping track of the scope within which it was defined. So let's say we have a method like this. We have this method called make method, and all it does is define a method, right? But we have that closure here, and that closure is going to hold on to whatever the value of thing is, because later on you might reference that value. It doesn't know what you're doing inside that block, so maybe you'll reference that value at some point. So we see down here, well, make method nil, that's just going to hold on to a nil, and nils aren't ever allocated, so that's not going to use up much memory. But the second one here is going to hold on to this giant string. So that's what it means. That's what this comment means, saying that it uses a lot of memory. But really, it depends on how you define that and how you define that block. It really depends on the context within which that block was defined. So, okay, well, you know what? Let's do a memory test. Let's do a test on memory and try and figure out which one actually uses more memory between define method and module eval. We know that this define method one will use up a lot of memory in certain cases, so let's write a test. Here we define 100,000 methods. Okay, one will use eval and the other one will use define method. So we're going to define 100,000 methods here, and then just sleep because I want to go look at the memory in the activity monitor. So I run this, and this might be small for you to read, but one of them uses 120 megabytes and the other one uses 68 megabytes. So which one uses more memory? Actually, the one that uses module eval is the one using 128 megabytes, and the one using define method is the one that's using 68. So which uses more memory? Again, the answer is it depends. It depends on how you called it. It depends on how you use it. So why is module eval using so much more memory than define method? Well, it turns out the reason module eval is using so much more memory is because every time you call module eval with a string, it's actually invoking the Ruby parser and converting that code into instruction sequences. And those instruction sequences aren't thrown away because they have to be executed at one point. Whereas with define method, we're only executing the parser once, right? So if we count up the number of instruction sequences, which we can do here at the bottom, again, you don't need to write this down. I will put up the slides. You can count the instruction sequences and we can see the difference. So let's run it once. let's run it once with module eval and run it once without module eval and look at the difference in bytes. And we can see, okay, well, define method is using vastly fewer instruction sequences than eval is, module eval. So, well, okay, so I guess we have to refactor our comment again. It says define method uses more memory because it creates a closure. Well, not necessarily. Maybe it depends on how the closure is created. So, okay, let's delete that. Now the comment says, we want to generate methods via module eval rather than define method because. And this is exactly what's going through my head when I'm looking at this code. I'm like, because. Who wrote this comment? Get blame. Anyway, so another interesting side note is let's also look at boot time. Which one's faster on startup? Which one of these will run faster on startup? And it should be pretty clear from now which one's going to be faster. So we'll use exactly the same benchmark, but we won't sleep at the end. We'll run the two, right? So we run the two, and the eval version takes 3.6 seconds, where the other one takes 0.6. So that's pretty interesting when we think about it. Module eval, despite what this comment says, all of our tests have shown, well, module eval is using more memory, it's slower, what is the deal with all this? But it really depends on how you're calling it, right? Really depends on how you're using this. So as far as memory is concerned, module eval seems to be using more, depending on how we call define method. So if we define our lambdas correctly, then define method's not going to use up as much memory as module eval. It depends. So boot time, module eval is definitely slower. Calling module eval so much, we're invoking the parser and parsing and compiling all this Ruby code. It's definitely slower than compiling it once. Now, as far as runtime is concerned, define method with a block is very slow compared to our module eval version. You're saying, but Aaron, what about the other define method? Yes, the other define method, this one. Can we use this one? It would be nice if we could use this one. The problem is there's nothing dynamic about this. And if you look at the code that we're generating, it's actually dynamic. We have a dynamic value here. This name thing is dynamic. So how can we get the best of both worlds out of this? And the way we do it is with method transplanting. I have to go quickly. Method transplanting. I want to show you a little bit of method transplanting. You can transplant methods using define method. So here's an example of transplanting methods. We say, okay, let's take a method from class A and put it onto class B. I would like to take one from class A and put it onto class B, but when we run this, we actually get an error saying, well, the bind argument must be a subclass of A, meaning that class B needs to be a subclass of A. They have to be related somehow, otherwise it's not allowed. But what about between modules? What if we had a module that contained all possible methods and then transplanted that somewhere else? Well, we can actually do that. With Ruby 2.0, we can say, okay, let's transplant methods between modules and then just include the module, right? This sounds crazy, I know, right? Let me say that again. We're going to define all methods and put them in a module and then transplant them. But we can do that. We can define all the accessors. And that's actually what we're going to do. We're doing this in Rails master today. So here's example of the code. We define all the accessor methods and actually transplant them. And that's what this code is doing here, and we're benchmarking it, right? So, well, actually, I'm sorry. Let me describe this benchmark a little bit more accurately. What this benchmark does is it creates a whole bunch of models, a whole bunch of active record models, and then calculates the number of instruction sequences that are generated during creation of that active record model. So what I want to show you is a graph of before. This is Rails 4.0 is before, and after, which is master. And this is a graph of the instruction sequences used between the two. That top one is Rails 4.0, and that bottom one is master. And you can see we have linear growth in both of these. So we're also doing a linear growth in active record models. So we're doing linear growth here. And if we divide this out and figure out how many kilobytes per model we're generating, in master we're generating 18K per model, and in Rails 4 we're generating 31K. And what's interesting is We can also compare definition speed. If we look at definition speed in master versus 4.0, we'll see that master can actually define an active record model almost 2 times faster than 4.0 can. But we have a remaining problem here, and if you notice in that benchmark, we had 100% cache hit. We were generating a whole bunch of models with exactly the same attributes, 100% cache hit, but the memory still grows. So somewhere we're defining a bunch of instruction sequences so that we're not caching. So we have a bit more room to improve there. The other problem is this only works on Ruby 2.0. It does not work on Ruby 1.9, this trick. So to recap, we went from querying to fixing a bug to security to performance, to instruction sequences, to Ruby source code, but we never fixed the bug. You'll notice in this talk. Don't worry, the bug actually got fixed. It's okay. And to recap, what I want to end with is don't believe everything that you read. Yak shaving can be fun and educational, just don't get too lost. Thank you very much.